Alright, so if I take a look at 17, they wanted us to evaluate the function for when x is equal to negative 3. Alright, and 17 was... Dude, I think I just did it for you on the board. F of x is equal to x squared. Isn't that 17? Alright, so all I'm going to do is substitute that negative 3 in for my x in my function notation, and I'm also substituting that negative 3 into my x for my equation. And now I'm just going to do my math. So f of negative 3 is equal to, what's negative 3 times negative 3? So this is just simply 9. So f of negative 3 is equal to 9. This is not f times negative 3. This statement says f of negative 3 equals 9. That's what that says. And that is function, put your hands out please, that is function notation. So that is not f times negative 3. Are you good with that? Chris? That's function notation. So this is a function notation. So instead of saying y equals, there's something called function notation, and we use f of x, or g of x, or h of x. This is just something called function notation. And what it allows us to do, it allows us to say what the value is for x that we're putting into the equation. So instead of saying y equals x squared, and when x is equal to negative 3, y is equal to negative 3 squared. Instead of saying all of this, we use function notation. It's just another way of saying y. You just say f of x. What else can I do for you guys? 43. Alright, let's take a look at 43. Alright, so they tell us that f of x is equal to 2x, and g of x is equal to x squared plus 1. So we need these two functions. And then they say, we want to do the math. F of positive 3 plus g of positive 4. What this means is, f of positive 3 here means I'm going to take my f of x equation and I'm going to substitute 2 in for the x. So if I was to rewrite what this says, well, f of 3 means I have 2 times 3, because f of x is 2 times x. So I'm just taking that f of x and I'm substituting it into here. So really what this means, let me write this again. Really what this means is, I'm going to take my f of x equation and I'm adding it to my g of x equation. Well, my f of x equation is 2x plus my g of x equation, which is x squared plus 1. But they're telling us what to put in for the x in my f of x. They're telling us what to put in for my x in my g of x. So this is 2 times 3 plus 4 squared plus 1. And now I'm just going to do this math. Well, 3 times 2 is 6, plus 4 squared is 16 plus 1. So this is going to be 23. So all of you right now go to number 45, and do 45 on your own. Because if you had troubles with 43, my guess is you had troubles with 45. 45 is still using the same thing. F of x is 2x. G of x is equal to x squared plus 1. And what they're telling us to do is, they want us to do f of 5 minus 2 times g of 1. So now that I did the first one for you, that 43, I want all of you to do this one if you didn't get it right. So everyone's taking a look at their number 45 and seeing if they got it right. If they did it, you're redoing it now. If you had troubles, ask someone by you. Work it out together if you need to. Alright,
out, please. So try to use 43 as your guide of what to do. So you should all be substituting. F of 5 means that I'm taking my f of x, which is 2x, and I'm substituting 5 in. So this is 2x minus 2 times, well, g of x is x squared plus 1. So I'm just substituting 1 in for the x in g of x. So that's 1 squared plus 1. So I have to do, oopsie, this should be 5. I should be doing that math first. So I have 10 minus 2 times, well, what's 1 squared? What's 1 squared, Peter? 1, so that's 1 plus 1. So I have 10 minus 2 times 2. So this is 10 minus 4, which gives me a 6. Alright, because they told us what they wanted us to substitute in to my f of x function, that was 5. They told us what to substitute into my g of x function, which was a 1. So Nick, are you cool with this? Are you sure? Okay. So I'm glad. I want you to, that's what I want to hear. So let's take a look at what we're doing. So let me cover this up and let's walk through this again. So Nick, are you good with what they're asking? So here's my f of x right here. Are you good with that's the equation for f of x? Okay, so f of x is equal to 2x. Okay, g of x is equal to x squared plus 1. Okay, so here they're saying we want to take our f of x when x is equal to 5, and we want to subtract off of it 2 times my g of x when x is equal to 1. That's what this is saying. Okay, so off to the side here, let's think about this. If I have f of x is equal to 2x, and I want to evaluate that when x is equal to 5, I just substitute 5 in for the x, Nick, in my f of x. Do you understand that? Okay, so I'm just going to substitute 2 times 5. I just substituted my 5 in for my x. Are you cool with that? Alright, so what that means is that f of 5 is equal to 10. So I need that. Are you good with that? Okay. Then they said, I need my g of x, which is x squared plus 1. Well, I need to know what g of x is when x is equal to 1. So I'm just going to substitute that 1 in. So I have 1 squared plus 1, right? So 1 squared plus 1 is going to be 1 plus 1. So g of 1 is equal to 2. Are you good with that? Because all I did was substitute 1 in for my x in my g of x equation. Chris, you're paying attention because this is something you have to understand as well. You weren't here. So g of x is x squared plus 1. This told us, they said, I need to multiply 2 times g of 1, which means I have to substitute 1 in for my x in this g of x equation. So when I do that, I get 2. So I just substituted 1 in for my x. So 1 squared plus 1. So 1 plus 1 is 2. Are you good with that? Okay. So now all I did is, I did all that work here. So now what I do is I just substitute these back in. Well, f of 5 is 10. G of 1 is 1. But I have to, according to this, I need to multiply it by 2. So g of 1 was this value of 2. 2 times 2 is 4. Do you understand? Awesome. What else can I do for you guys? Sam? I take a look at 25, 25 said, I have the function rule y is equal to 5x minus 2, and I want to evaluate it for this domain. So my domain is negative 5, negative 1, 0, 2, and 10. Sam, is this the one you're talking about? Okay. So the domain is the variable that's inside the equation. So that x is my domain. So I need to evaluate this equation for each one of those numbers individually. Okay? So when x is equal to negative 5, I would have y is equal to 5 times negative 5 plus a negative 2. And I would do that math. Alright? When x is equal to negative 1, I would have y is equal to 5 times negative 1 plus a negative 2. And I would do that for all of them. Is there one of those domain values in particular that you want me to show you the math for, or was it just I didn't know what to do? The first one. So that negative 5? Awesome. Alright, so 5 times negative 5, Sam. Negative 25. Sam, did you do adding the opposite here? Oh, well, look at your note. Look at your stuff. Okay, so 25 plus a negative 2. What is 25 plus a negative 2? No. Negative 25 plus a negative 2. Negative 27. Okay? So this one is when we were not using function notation. And when we're not using function notation, I do need you to indicate what x value that you're using when you evaluate. Alright, put this away and get your notes out. Alright, we are moving on to 5.3. Yes, Serena. You could use your calculators. We're doing math. Like we're actually doing calculations, so if you'd like it, you can. You do not have to. You could use your brain. No, everyone's getting their own calculators if they'd like them. Come on, let's go. Come on, let's go. Alright, so we're starting 5.3. We're still talking about function rules, tables, and graphs. Colin, how are we doing with your notes? Oh, that's awesome. So you're just going to start at the very beginning and do one page at a time, right? Awesome. Make sure you're all having your notes done right. Each day of notes should be right after the one right before it. Okay. Let's review when we are talking about functions. Alright, there are three ways to show a function. The first one is a function rule. What's another name for function rule? What did I tell you guys yesterday was another name for a function rule? It's a word we use more likely, like all the time I use this word. Serena, put the calculator down. What's another word for function rule? Ava? Yeah, it's an equation. That's the same thing as equation. So function rule just means an equation. And it's an equation showing what the rule is for a table, or what the pattern is, what the relationship is in the data. Alright, the second way that we can see a function is in a table. And the third way was a graph. We've already talked about these three ways. Alright, today we are going to be creating tables and then graphing them. So we're going to be using all three of these ways today.
let's review something. So when we have independent variables, that's usually our x. It's usually our x values. I'm going to put in parentheses or the variable within the math in the equation. All right, these are also our domain values. These are all words for the same thing. They're also our domain values. They're also our inputs. It's the values we're putting in to get our range values or our independent information. All right, so we talk about our dependent variable. Those are usually our y's. Usually the y values. These are our range values or our outputs. All right, so if we're taking a look at examples, I'm going to do two examples, just looking at two examples. We might have y is equal to 3x squared plus 1. What variable in here is our independent variable or our domain or our inputs? What variable here is that? Isabella? Yeah, our x is our independent. What then is our dependent? Jacob? That's your y. Because our y depends on what we put in for our x. All right. If I had t is equal to 3c plus 1, what is our independent and what is our dependent variables? Nick? Dependent? Yep. Excellent. You guys cool with that so far? Okay, so what we're going to do is we are going to create a table of values that I want you guys, from an equation that I want you guys to graph. Okay? Who needs to see what's up there? Andrew, are you good? I just asked if you needed someone who needed to see this, so nobody raise your hand. Are you cool? Awesome. All right, so what we're going to do is we're going to create a table of values for an equation and graph it. For you to graph an equation, you have to have a table of values. All right, so to graph an equation, you must make a table of values. At least for what we're doing now. Once we get into linear equations, we are going to be finding an easier way to make a graph based on the equations that we're given. Okay, you do need your rulers, so get your rulers out, please, because we're going to be graphing. So you do need your rulers or your protractor. Everybody should have a ruler or a protractor. If you're borrowing from somebody, that means you need to go ask your sweet mom or your sweet dad for a ruler or a protractor, something with a straight edge. Okay. If you're not given domain values, if not given domain values, this is what you're going to do. Coefficient and integer. You're going to use -2, -1, 0, 1, and 2 as your domain values. Just let me finish, please. If not given domain values, coefficient and integer, these are the values you're using for your domain. All right. If your coefficient is a fraction, all right, your domain are going to be multiples of the denominator. All right, you need 5 points total. That's my rule, 5 points total. Because I want to know what's happening in the negative section and the positive sections of our graphs. So in our coefficients and integer, we're going to be using, our coefficients and integer, we're going to be using just -2, -1, 0, 1, and 2. I'm going to keep it as close to the origin as I can. When our coefficient is a fraction, our domain is going to be a multiple of the denominator. Questions? Ava? Okay, so let's go ahead and do one. Yes? Points? 5 points total. So I want you to graph 5 points total. Is that what you're asking me? Yeah. All right, so let's go ahead and do this problem. I want you to graph y equals 1/2 x plus 3. You may use your calculator to help you if you need to, but you're really not going to need to. All right, because you're just going to put these values in and do the multiplication. So let me ask you guys, my coefficient is a fraction. What values for x should I use? I need 2 negative, I need 2 positive, and I need 0. So what numbers am I going to use if my coefficient is 1/2? Isabella? What multiples of the denominator can I use? What multiples do I have? From what multiples would I use? What are multiples of 2? So tell me a multiple of 2. So 4. So I have -4, -2, 0, 2, and 4. That's all I'm looking for is multiples of 2. So I would use multiples of 2 as my x values. Do you guys understand that? Okay, so let's go ahead and evaluate this equation for those values. So you're all doing the math, substituting those values in for x. You might see a pattern happening, and that's fine, but I still want you doing the math, and that way you know if you did it right.
So we're dividing out common factors, which is why we used multiples of 2. Don't copy mine down. Do your math. So you're substituting each of these x values in for the x in the equation, and you're solving for your y. Do not write mine down. You're figuring this out for yourself. So you're substituting all of those x values in for your x, and you're coming up with your y partners. And then you're graphing. Nick, why do you have your hand up, dude? What do you got? You're just substituting those x values in for x in the equation, and you're solving for y. So when I substitute negative 4 into my equation, I have 1/2 times negative 4 plus 3. And you're just going to divide out common factors between the 1/2 and the negative 4. So you're just doing the math. So you're substituting those x values in, and you're just doing the math to find the y value. So this is what I should see for all of them. I substituted negative 4 in for my x, 1/2 times negative 4, where I can divide out common factors, so I get negative 2 plus 3, which is 1. I should see all of that math. You're all sitting up to your desk, you're all looking at what you have for your math. How many of you guys got those values for your y's? Okay, now you're going to graph. All right, you're using a ruler. I should see x and y on your axes. I should see increments drawn on all of your axes, at least as far out as the data. And then you're going to graph. Put the chair down. So this is what your graph should look like, and we are going to connect them. So we are going to create that line. Questions on this? So Nick, do you understand? What I need you asking questions. What don't you understand? Do you know how to graph? Okay, so all I'm doing is I'm graphing this table. I have the coordinate point negative 4, 1. I have the coordinate point negative 2, 2. These are all individual coordinate points on my table that I am now graphing on my graph. Do you understand? So negative 4 means I'm going to the left 4 places on my x-axis. 1 means I'm going up 1 on my y. Questions on this at all, please ask. Don't be shy about asking. How many of you guys are good with substituting those x values into the equation and finding the y? How many of you guys are good with that? All right, remember, if your coefficient is a fraction, you're using multiples of the denominator. Keep them as close to the origin as you can. If your coefficient is an integer, means not a fraction, you're going to be using negative 2, negative 1, 0, 1, and 2. Questions? All All right, if you guys are done, you guys can go.